Titanium is a relatively inexpensive metal. In fact, it weighs about 60% less than aluminum alloys. There are a number of alloys that contain titanium as a minor component. These alloys are usually two-phase mixtures. This allows for a variety of microstructures that can be tailored to the mechanical properties required. This element is usually distributed in low concentrations and is considered harmless. Titanium is likewise one of the metals that has the highest resistance to corrosion. The United States of America and the Soviet Union were engaged in a competition all through the Cold Wars to determine who would control the market for titanium. They each considered the element to be a strategic material. A series of military aviation programs was launched in the late 1940s and early 1950s. Some of these programs included SR-71, F-100 Super Sabre, and Lockheed A-12. However, the American military was initially skeptical about using titanium. This is because the titanium found in Henry Moissa's experiments was heavily contaminated with oxygen and nitrogen. The chemicals manufacturing sector has seen dramatic transformations since the advent of titanium. The history of titanium is a long one. The first known discovery of titanium was made by an English clergyman named Reverend William Gregor in 1791. He discovered a black metallic sand in a stream in Cornwall, England. He reported his findings to the Royal Geological Society of Cornwall. Later, a German chemist, Martin Heinrich Klaproth, found elemental titanium in a rutile ore. For some reason, he thought the Titans from Greek mythology would be a fitting name for this new metal, so he went with titanium. He also discovered and isolated this element independently. However, it took over 100 years before it was isolated and developed. Titanium is a metal found in nature, including the Earth, in meteorites, and in the stars. Titanium was first isolated in pure form in 1910. This element is found in minerals such as ilmenite and rutile. These minerals can form deposits in soils or in heavy mineral sands. Titanium oxides may be present in a variety of high-pressure igneous rocks. As far as titanium compounds go, titanium dioxide is the least widely used. Titanium, therefore, is incredibly tricky to mine in its metallic form. Rather, titanium is usually obtained in low concentrations. However, in the 1940s, William Justin Kroll developed a process for producing titanium. Using this method, he was able to produce metallic titanium. Titanium is highly corrosion resistant and it has a high strength-to-weight ratio. This element is also a light metal. Ti is corrosion resistant, making it a good choice for chemical and petrochemical processing. Titanium is among the metals that has the ability to withstand the test of time the best. Titanium is a low corrosion material and has the strength to resist fire. It has a tensile strength of over 1,400 MPa, which is equivalent to about 200,000 psi. There is no impact on the material's eventual tensile strengths from the presence of deformations in the alloys. However, high strength can cause cracking during machining. Titanium has an unrivaled corrosion resistance and good creep resistance. Moreover, titanium alloys have a high strength-to-weight ratio. This element is also a very biocompatible material and is non-toxic. It is also non-flammable. It can be cast, forged, or welded into shapes. It has a silvery, iridescent appearance. Titanium is also highly conductive. Titanium alloys are a great option for electrical components since they have high conductivity and excellent corrosion resistance. They are unaffected by the majority of acids, alkalis, and liquid water. Titanium has the potential to generate a protective oxide coating, which stops additional corrosion from occurring. This is another advantage of titanium. Titanium is a strong, corrosion-resistant metal, which is used in many applications. In addition to not being magnetic, it has an excellent strength-to-weight ratio. Because of this, it is an excellent choice for use in goods that are in direct touch with either chemicals or bodily fluids. The layer grows slowly, but can reach a thickness of 25 nanometers in just 4 years. Titanium is able to maintain its stability as a result, making it an excellent substance for heat exchanges. One of the earliest uses of titanium was in military applications. The Soviet Union was the pioneering nation in the usage of this material for submarines and airplanes. In the 1950s, titanium was used in high-performance jets. Titanium is a metal which is used in a broad range of different applications. This element is found in many forms, from its use as a basic material for automobiles to its use in high-grade medical equipment. It is especially useful in products that come into contact with chemicals. So titanium is very useful in aircraft. Despite being a relatively new material, titanium has quickly made a name for itself in the aerospace and aerospace parts industry. This element is also now used in automobiles, jewelry, architecture, and sports. It is also useful for marine projects. Additionally, titanium is put to good use in a variety of agricultural and industrial applications. Its chemical properties make it useful in high-performance jets, as well as in prosthetics and other devices. Today, titanium is widely distributed and one of the most common alloys in aerospace and aviation. This element is used in the A330, A340, Boeing 777, and 747. Titanium is also found in hydraulic tubing, firewalls, and landing gear. It is used for dental implants and orthopedics. The chemical industry is the largest user of titanium. Typical applications include heat exchangers, reactors, and vessels. The aerospace industry also uses titanium, primarily for lighter parts. The corrosion resistance of titanium is especially important in the chemical industry. For example, its high corrosion resistance is important in the nuclear power station industry. Equipment that is used to process inorganic acids and salts is often exposed to them, and titanium has a long life in these environments. Medical devices such as pacemakers, surgical implants, and cardiac catheters are commonly made of titanium. However, there are other applications as well. Because of its strength and weight, this element is ideal for demanding applications. Chemical processing equipment is also a common use for titanium. Several other applications of titanium include heat exchangers, piping systems, and heat exchangers. They are also used for electrical components and surgical instruments. Various types of titanium alloys are used in the aerospace industry.